Hello everyone. In this session of CCNA series, I will discuss one of the layer 2 security feature called switch port security. In today's enterprise network, security must be implemented in depth. We use firewall and intrusion prevention systems at strategic locations and ensure hosts have updated antivirus and anti-malware tools. Routers at the edge between LAN and WAN should be configured with IP access control list to filter packets. Securing LAN switches is equally important as endpoints are connected to endpoints are connected there and are vulnerable to attackers. The attacker might gain access to those devices connected to LAN switch or infect them. Roaming devices can also be infected while outside the company network and pass on the infected virus when connected back to the LAN network. So, Cisco switches include several useful tools to help prevent several types of attacks, such as one of the tools is port security, and another one is DHCP snooping and ARP inspection. So, we will discuss about port security in this session, and we'll discuss about DHCP snooping and ARP inspection in another session. So let's go ahead and discuss about switch port security. As you know, switches are fundamental devices in the network, responsible for connecting multiple devices such as computers, printers, servers within local area network or LAN. They operate at the layer 2, that is data link layer of the OSI model, and use MAC address to forward data to the correct destination. By default, all ports on Cisco switch are in enable state, and anyone can potentially connect to any of those ports, posing a security risk. So, securing the switches is really important to stop or prevent unauthorized access to the LAN and ensure the integrity and reliability of the network. So, let's look at some of the concept of switch port security. The switch port security features offers the ability to configure a switch port so that traffic can be limited to only a specific configured MAC address, like or a list of MAC addresses. If the network admin is aware of what devices should be connected to a particular port on a switch, port security ensures that only authorized devices with recognized MAC address can use it. If an unauthorized device uh, attempts to connect, you can configure the switch to take different actions, ranging from simply issuing informational messages to effectively shutting down the interfaces. So, port security actually identify devices based on, as I said, source MAC address of the devices. So, switch can learn MAC address from directly connected devices or from other switches. As you can see on the top right, there are three PCs connected to switch, but it can also learn from another switch as well. Port security has no restrictions on whether the frame came from the local device or was forwarded to the other switch. If you see the MAC address AACC, it came from other switch because the PC is connected to the other switch. Port security has various flexible options but follows the same basic principle because each switch port can have a port security enabled with different settings. Like each port has a limit on number of allowed MAC addresses. For example, if you see the port which is connected to switch has a maximum limit of 3 because you might right now there are 3 PCs connected, and by default actually on each port the default limit is 1. So if the number of different source MAC addresses exceed the limit, a port violation occurs. So we'll look about what happens when the port violation occurs. But before that, let's see how we can secure these MAC addresses. There are 3 ways you can secure MAC addresses. One is by static secure MAC addresses. Here the MAC address is statically configured on a switch port and it is stored in address table and in the running configuration. The second option we have is dynamic source secure MAC addresses. Here the MAC address is learned dynamically from the traffic that is sent through the switch port. These type of addresses are kept only in address table and not in the running configuration. If you see the difference in static, you configure the MAC address and it will display in the running config. And the third one is sticky secure MAC address. A sticky secure MAC address is a key feature of the switch port security that combines the flexibility of dynamic learning with the stability of static configuration. A sticky MAC address is dynamically learned by the switch and then saved in a running configuration as if it was statically configured. This allows the switch to remember which device are allowed on each port even after the reboot without requiring manual configuration of each MAC address. So this feature helps reduce the big effort of finding out the MAC address of each device. So these are the three different secure way of securing MAC addresses. Now let's discuss about what happens when your MAC address or any unauthorized device accesses. So this is where the port security violation modes come into picture. The devices responsible to a violation can be configured in three different modes, or I would say four different modes. First one is protect. This mode permits traffic from known MAC addresses to continue to be forwarded while dropping traffic from unknown MAC addresses when over the MAC address, allowed MAC address limit is reached. When configured in this mode, no notification action is taken even when the traffic is dropped. So when it violates in this mode, there is no notification. It will forward the known MAC addresses and it will drop unknown MAC addresses. The another option we have is restrict mode. This mode permits traffic from known MAC address to continue to be forwarded while dropping traffic from unknown MAC addresses when over the allowed MAC address limit is reached. So when configured with this mode, a syslog message is logged, an SNMP trap is sent, and a violation counter is incremented when the traffic is dropped. If you see the difference, this informs the machine that violation has occurred, whereas in protect, it remains silent. Another option we have is shutdown. This mode is the default violation mode. So when in this mode, the switch will automatically force the switch port into an error disabled state when the violation occurs. While in this state, the switch port forwards no traffic. The switch port can be brought out of this error disabled state by issuing the error disabled recovery CLI cause CLI command or by disabling or re-enabling the port. Another option we have is in shutdown is VLAN. This mode mimics the behavior of the shutdown mode but limits the error disabled state for the specific violating VLAN only. The previous one, entire port, this one only for the particular VLAN. So if you go ahead and compare the main points of these three modes, we can compare it this way. For this, which one discards offending traffic? In protect mode, yes, it discards. Restrict mode, yes, it discards. Shutdown mode, it discards. In three modes, it discards the violated traffic. Whereas whether it sends log and SNMP messages in protect mode, no. In restrict mode, yes. In shutdown mode, yes. And the last one disables the interface by putting it in error disabled state and discarding all traffic. Protect mode, no. Restrict mode, no. Only in shutdown mode, it puts it in error disabled state. That's it for this session. I hope this was informative for you. Thank you for watching.